you very much, Alistair, and good morning, everyone. So yeah, I'm Adam Jones, as Alistair mentioned. So my timber journey really started since university. So in my fourth year, Colin Capreni was my lecturer at the time, and he said the future is actually in timber and low embodied carbon materials. So as everyone who's an engineer right now would understand, we only learn concrete and steel at university. So it was that's where I really took the plunge and used mass timber for the final year project. And yeah, after that, I joined WSP as a structural engineer, and luckily, Alistair Woodard, I went to one of these seminars that Alistair hosts, and Alistair, I think I left my jacket in at the end of the seminar, and Alistair said, "Let's catch up." And anyway, long story short, I joined WoodSolutions after that, and yeah, really loved the timber industry since, and it's something I'm really passionate about, and excited to start this new journey with the new software solution that we're working on. I think that just also stems back to university. So you go to uni, you learn concrete and steel, it's super easy. Then you go into the workforce and you got mentorship and a lot of industry experts with over 10 years experience, and then there's software solutions. When it comes to timber in the mid-rise sector, it's pretty much nothing. There's nothing at uni really. There's no software solutions. You got to go out and build spreadsheets. There's no mentors out there with over 10 years experience to tell you how to do it. So what we're trying to do is really build infrastructure. So the idea is if we can make timber easier to design within concrete or steel, then we can actually drive the adoption significantly going forward. And that's one of the things we're trying to do at the moment. So I'll share my screen. As Alistair mentioned, I was actually the original host at the very start of this webinar series. So it's really cool to come back in that sense as well. So it's probably, take a step back again. So in this presentation, I'm going to talk a bit about the context of the problem we're trying to solve. I just mentioned a little bit about it then, how we're just trying to make it easier in our strategy going forward. And following that, I'll show you the software. So we'll jump in it. We currently do have a beta user program with a bunch of users in it right now, and we're at a second release. So we're still early in our journey, but we are operating fast as the team builds. So in this sector, it's not rocket science to know that the demand is increasing. If you look at the embodied carbon target reductions across the board from developers like Lendlease and Frasers in the private sector, but also in the public sector like New Zealand, the New Zealand Building Code, for example, they're making it mandatory to report embodied carbon and then starting to ratchet it up in terms of targets. And Australia's not far behind. So as our buildings become more operationally efficient, with renewable energy and improved energy efficiency and things like that, the proportion of impacts is increasing as we go forward. That comes from structural materials. So there's a huge spotlight on it. Cement and steel, it's above 8% of the world's greenhouse gas emissions, more than the cars on our roads. And that's starting to get a lot more airtime as we go forward. It's a much harder issue, I think, than operational energy, but it's an issue that can be solved. So that's sustainability. And then also it's just a different product. So especially when it comes to exposed timber, there is proven benefits as a biophilic design element. There's different patterns about biophilic design according to Terrapin, and one of them is designing with natural elements. We did design to be in natural materials, not in dog boxes with no inspiring nature around us. And there's loads of research to back it up, the benefits of biophilic design, better productivity, employees taking less sickies, improve stress levels, and all these sorts of things. So if you're the owner of one of these assets, you actually have a better ROI on the asset itself. And even if it does cost a little bit more, there is a payback period. There are numbers that vary, but what commonly used is about 5% as a reasonable number of what that improved rental yield might be. But it doesn't matter how big the drivers are in terms of demand, there is bottlenecks to the adoption here, and that's one of the things we're trying to target in our sort of our medium to long-term roadmap, is just to look at the bottlenecks more broadly. So at the very beginning, we got the client and architect, they're wanting a lot more timber for obvious reasons. In design meetings, I don't think there's too many saying no at that stage, because we are dealing with this better product, and from a triple bottom line point of view, something that can be better as well if designed properly. But then if you have the architect who wants the building, then they got to find their project structural engineer. And around the country right now, part of the research we did, part of the business and things like that, we got, say, 10,000 to 11,000 structural engineers across Australia and New Zealand. Out of that, we've got out 1 in 300 are true mass timber specialists or timber specialists in the mid-rise context. That means if the architect just shoots for their usual engineer, it's almost certain that it's not going to be someone who could take the design forward. From my personal experience, a lot of the time, if it's not one of the timber specialists, engineers a lot of the time might not put their hand up and say, I don't want to do it because I don't know how. A lot of the time there'll be other reasons put out instead of just not being able to do it, because no one wants to say that to a client. But then you got quantity surveyors as well. So say if it does get designed structurally and it goes to the quantity surveyor, if you've got a traditional quantity surveyor who may not want to put the time and effort into raising the benefits of timber, things I'm talking about is speed of construction here is one. So if you build faster and then you've got things that have $1 per week cost, you reduce the weeks in it and you get a direct cost saving, that's significant. And then you've also got other things like foundation savings being 1/5 of the way to concrete, which works out to be about half the overall dead load in general. That has huge savings as well. So what I mean by proactive quantity survey here is, rightly punishing timber where it needs to be punished in terms of its material versus material supply costs, but also looking at the benefits of timber and pricing that in properly also, because that's what holistic pricing means. And if you look at it holistically, that's where we get closer to parity or even better on some projects. And third, I'm aware there's a few building surveyors on the line, and so there's a lot of subjectivity when it comes to fire design around the community. It does, again, I think, come down to competency, education, and experience, because every professional across the board are going to whack on their conservatism bias on top of it. And when it comes to fire engineering, when there's a lack of knowledge, it's always compensated by risk reduction, and sometimes in different ways. So there's huge subjectivity there. You got one building, it might be a fully exposed mass timber building, 3 stories, and then you got another one, seemingly same building, but you got 3 layers of 16 mil plasterboard, and it was very hard to get across the line. So compliance and fire engineer, it's something that's currently subjective, and that being a bottleneck as well is that variability. And that's what where we are right now in terms of the adoption. We're less than a drop in the ocean compared to what concrete is. So one of our values as a company is to grow the pie as much as possible. We don't have to worry about cutting the pie at all, because we're cutting the pie on something that's just a tiny, tiny fraction of the overall market. If we solve collective problems, we can grow the pie significantly and then improve things for everyone, and have a net positive contribution to sustainability. So us as a company, say that's the overall arching bottlenecks. What we're trying to solve is one specific part of this bottleneck diagram I showed you before, and we're focusing on the structural engineers mainly, and there are secondary benefits on other things like compliance and stuff like that, which we can talk about later. But there's 2 major problems. Number one, it isn't taught at university, pretty much you could say at all. I think you got a 4-week timber course where you do a bit of class 1 low-rise construction, but nothing in that mid-rise context. So that means the structural engineer on the job has to try and figure it out themselves. And there's no Australian standards. So that means, where do I start? What's the authority? These are really hard questions to answer. You've got guides in FB Innovations in North America, which are absolutely phenomenal. ProHoltz has got guides, which are phenomenal. You got Euro codes, you got local standards, you got New Zealand standards, you got WoodSolutions, you got 50 guides. Someone's starting their journey, it's a very hard task. And then to know what the authority is and when to bring the right design method in for the right context as well. We've got different species in Australia. So where is it applicable? If you're using Euro codes, can you use that for the local context when it comes to design methods? And these are things that every single engineer has to ponder at the start of their journey. And I'll talk about later about replication costs. The second problem is the reinvention of the wheel doing the same task. So that means every engineer, when there's not a software solution, they build spreadsheets to fill the gaps, and everyone's building the exact same spreadsheets, whether it be WSP, ARIP, ACON, TTW, building the exact same spreadsheets. So there's reinvention of the wheel, which drives up the overall costs. And then without the education, which is the first problem, a lot of the times it could be an inaccurate design. It took me about 20 iterations of the same spreadsheet before you actually got confident on actually what you're designing, and that's a multiple year sort of thing. And then also, as new design methods evolve, all spreadsheets become redundant. And it's not just for engineers, it's also for the supply chain. If you've got a design guide with span tables underpinned by a certain vibration method, for example, upgrade the vibration method. You got to reproduce all your material for your design guides, and then somehow get that manually over to the engineers as well. So part of our research, we interviewed mass timber specialists around the country. We asked them how long does it take you to actually build out your CLT floor design in the ambient case, soft Excel spreadsheets, how long did it take you to learn reading all the design guides like I mentioned before. We did that for every single element that is in the, say, the timber design ecosystem, and did it for 3 types of buildings. So you've got a post and beam building with CLT floors, GLT beams and columns, and then we grouped up all the things you need to design there. We did the same thing for a hotel building with CLT walls and CLT floors. And then we did the same thing for a light frame building with light frame walls and CLT floors. And that's not the full set of computations you can see there, but and the time that it took what it came down to is about 500 unpaid learning hours. So if you're doing this for the first time, without the education, with the need to build spreadsheets, starting your journey to get to the point where you can design this, it'll take you about 500 hours that it's not required for a concrete and steel building where there's existing infrastructure. So that means if you are putting a design fee in from one of these projects, if you're trying to be competitive with those who've actually made this step so far, you got to essentially run it at a loss to actually be competitive, because you're spending more money and time at the start figuring it out than the actual design fee itself is allowable for. So that's essentially what the bottleneck is for engineers. As I said, 10,000 structural engineers around the country, not many timber specialists. We're trying to give the tools for the 10,000 structural engineers, and I'll talk about that later. So if you think about the engineer, architect taps them on the shoulder and says, hey, I want to do a sustainable building. I heard timber's awesome. This is what their view. So they've got the status quo where they know how to do it and they make money. And then this other path, there's a lot of clouds and storms and demons and things like that stopping you. And there's just huge hurdles. And these are the bottlenecks individual for a structural engineer. And these are the hurdles that can be solved. So next I want to talk about this idea of replication costs. So like we were saying, every engineer around the country has to solve these hurdles themselves. And every time an engineer solves these hurdles, in one way or another, it increases the relative cost of the timber design compared to a concrete design. And that's replicated all the time. And there's ways we can actually reduce this replication cost using inspiration from other areas. If you think about when it comes to books, writing books, you've got J.K. Rowling. When she did Harry Potter, she wrote the book once and solved that problem once, and then used distribution channels to print it 1 billion times. She didn't have to print it for every individual reader. When it comes to ballet, which my partner's in, it's a similar thing. You do the choreography once, you teach it, and then you dance it as many times as possible. And also in the automotive industry, it's something where you design it once and you use it many times. And this concept is a bit foreign in construction. We don't solve the problem once and then use the concept of leverage. A lot of the time, everyone's going to solve the problem once individually from every individual engineer at every single company. So this is where we draw inspiration from, because the ultimate solution to solve problems once and be able to use the concept of leverage is software. Because right now, let's say someone's starting their journey, you could say they're a 1 out of 10, they're just starting, of course they're going to be 1 out of 10. They need to go through that river and the hurdles and get the scars and pain and everything like that on their journey to become a timber specialist. Say if they're to become an 8 out of 10, or through software and this idea of infrastructure, we can get the very best people around the region who I say 8 out of 10, 9 out of 10, 10 out of 10 in what they do, solve the problem once. They might be the PhDs in the specific topic and the best authority, leverage their brain, turn it into infrastructure. And that means the person just starting out, they're not starting out at level 1. They're using the concept of leverage to get the very best that the whole industry has to offer. And even from a global point of view, there's replication costs, not just when it comes to design, also compliance. There's duplicated conversations every time. What's the compliance pathways of GLT and CLT? Do I need fire tests? What are the fire tests available that we can leverage and not need them anymore? All these things are happening on every project, but through software, we can solve it once and use it many times. So that's what we're trying to do as a company. We're trying to leverage the very best people, thoughts and design routines in a very rapidly evolving field, and then get it accessible to every engineer. So their competence starting point is much better. So, there's attributes that we believe or we heard are super important. Number one, things not to be a black box. An engineer needs to be able to figure it out, because without the university education, this is an important attribute for any software, but especially for timber, being absolutely transparent and drawing out the computations as much as possible. Supply chain availability, that's important from both sides. Suppliers, you might have a design guide out from 2 or 3 years ago that the engineers are still using, but the grades are changing in the supply chain constantly, and distributing design guides constantly to actually get what products are available is a hard problem, and no one wants to design not what's available. But currently the method of using PDFs and emails doesn't enable a better way. Third-party reviewed. As I said, if we are trying to make the best design computations, if you're starting out for the first time, there's a very high risk of error on computations. That's just the way it is. And if we actually solve it once and then get the best third-party review process that you can get, then you're actually getting a much more reliable solution. And then at the end of that, you get the improved safety in design and competence and the risks of error that can come with people doing it for the first time and essentially just getting scars. And most importantly, is educational. So some things are quite complicated. Like if I think about, and I will show you the actual software with these a bit later, but just as a primer, something like floor fire design, there's a bit of a grey scope between what does the structural engineer do and the fire engineer do. And some suppliers have got fire design guides right now, and there is a DTS solution, so deemed to satisfy solution for your structural adequacy, integrity, and insulation. But it's only for simply supported and 2-span equal. It's not going to cover the range of cases. So there are times where you might need to step into performance-based design. Then you got effective stiffnesses. There's different methods around the world. Just sheer analogy I used to use, and it took me a while to realize that you can't use it for non-symmetrical sections, which is the case for fire design or designs where you've got different grades throughout the layout. Strength design, encapsulation, and zero strength delays, again, is something that's treated differently around the world, whether you be in AS 1720 most recently, but also in the upcoming Eurocode 5 is treated differently also. Or CLT floor ambient design. A lot of design guides out there by suppliers, they've got totally robust design methods underpinning the span tables, but a lot of them will have a different vibration method used to create the span table. So that means if you're using it for a prelim design and then you put that in for pricing, it might not be an apples with apples comparison if they're using a different vibration method. And also DFMA education. If we are going to drive down the cost of mass timber, more generally, we need to actually understand the implications. If you change your grid spacing by half a meter or something, little do you know as a designer, you might actually be the difference between a full truck and no wastage in terms of transport and maximizing crane and liftage and maximizing speed to actually reducing that by 50%. Little tweaks like that make a big deal, and getting that data from DFMA through to the hands of designers. And then point loads as well. That's again something that's it's actually quite a complicated thing to do, and to ask engineers to solve all that is a big one. So part of our plays, we're doing partnerships, firstly with the supply chain as well. So it's in contract phase with a lot of the mass timber supply chain right now, and that means getting the one-stop shop, because obviously if we're trying to grow the pie, make it as easy for engineers, then and we are in that grow the pie attitude and going from 0.x% market share and growing it by a significant proportion, then everyone wins there. Also associations and universities, especially when it comes to unis, they are the most progressive people on the planet, caring about sustainability in that cohort and that demographic, but all they're offered really is concrete and steel. So I'm aware that students really want to be proactive, and if they knew what their career impact was with their decisions and them learning how to design with timber, comparing it to their individual decisions, it's chalk and cheese, because by far the highest leverage you've got in that context is in your career, and at least knowing how to design timber when the right time is. So yeah, we're looking to partner with universities as well. It's not our immediate priority, but we're going to try and target fourth-year electives, because it's those points there where we don't have to rely on curriculum changing, and the engineers can proactively choose what they want for their final year project. And then also investors. So we've closed part one of a seed round, and we've got some really good group of investors on board, including a co-founder of AConneX, so Rob Philpott, who's from Gravel Road, also some other executives in investment banking background. Interestingly enough, BlueScope X have joined our journey as well. They've got their legacy business, but they've also got their decarbonisation arm as well. And then Archangel is our lead investor, and we're about to do another round of finalise a round in this week as well. So that's where we are right now. The team we've got, so we've just opened an office in Addis Ababa, Ethiopia. So Lalisi was the first hire we had as a structural engineer, and then so she was just that bloody good. She solved problems. She's better than me as an engineer, it turned out. See any mates, and Wonderate, her mate for a long time, joined her team, and then turns out their dream was to open an office. So we're right now just growing the team there. We're going to have 15 structural engineers by the end of the year. Addis Ababa, there's 11 technical universities, high unemployment rate. And that's one of our values. There's a lot of talk about equality sometimes, and you've got equality of opportunity versus equality of outcome. I think it's undeniable that everyone should have equal opportunity, which means it doesn't matter how talented you are. If you're talented and work really hard, you should have the equal opportunity, and nothing to do with outcome. And in the city, there are absolutely talented people out there who, with an opportunity, are going to have an awesome career. And then also we've got a software team in Semarang, Indonesia, on the bottom left here. Totally different culture from a software point of view as well. So we're just starting our journey, and we are just about to release our first release. As I said, we've got a bunch of users on the software right now, and we are looking to have light frame connections and hybrid as well there. With the idea, we solve the problem once and then use it as leverage to make it as easy as possible to drive change in timber construction. So with that said, that introduction, I might get into the software now. See, it's 11:26, so I've got one eye on the time. All right, so it is a web-based software. So that is the easiest way to do software, to sign up, and the most frictionless, and also can incorporate with the evolving software ecosystem in building information modeling, which we can talk about later. So it is element-based design software. So you can see here you've got all the individual elements to be designed. We've got a member design portal, which is here currently in progress. We've got one moment. We've also got a connections library coming up. Hopefully I remember my password here. That'd be embarrassing. I did. And also the connections portal here. So you can see here, as that's being built out, connections being the most complicated, and the connections supply chain is most likely who we're going to be partnering next. And we've started some conversations there as well. All right, so I'll speak about it as if I'm an engineer. So let's create a new project. Or you can calculate a project under an existing project. So let's go WoodSolutions Office, Floor, Fire 1. And I'll start on fire design just because I showed it before, and it is one of those things that's a tricky problem out there. It takes a long time to actually learn this. So I mentioned before, our most important value is as a software providers, is not to be a black box. So we use visual images all the time here to visually show what the software is at least trying to do. It serves a lot of purposes, but we have a serious review process, so there's no software errors. But if there ever was, if it's not a black box, it'll stand out like anything. It'll quickly be weeded out of the platform in a 2-week release cycle. So you got here the FRL on the x-axis, you got the grades on the y and the slab thickness. You've got the ability to do new layups, individual layups where you can just do your grades and build it from scratch. Probably don't recommend that. Probably recommend actually using what's available by the supply chain. So you can see here you've got the different options here from suppliers with all their supply chains ready to go. So you can see here I just chose a next timber panel. You got MGP 10s on the outers. Going through here, you got different design methods. So we've built in the local loading standard, local design standard AS1720 and Eurocode 5. So it is the ability to swap between suppliers and design methods as well to make things as easy as possible. And also with the loading code as well. Not being a black box, whenever you're uncertain about something, that's where we can have a drop down, and this is where we provide the education. So you can go, hey, what design method do I use? we have a bit of information on here, bit of a question flow diagram based on where you're actually designing, getting the material from. Moving through, when it comes to FRL, you've got the data, and being some building surveyors on the call right now, and this is, I think, has got a big opportunity to actually educate structural engineers on the compliance pathway, and we're always open to speaking to building surveyors as well and getting the right context in the drop downs and agreeing upon things. But for any case, we got the information on integrity, performance, insulation, bit of information about fire tests. And this is a second release. So I think on the FRL and compliance, we can really build this out. And then most importantly, have videos and education. And in this video, it's just a conversation I had probably 10 times at XLAM on different projects. And that was about what's the compliance pathway? Do I need fire tests? Why would I? Why don't I? All these sorts of things. We got the ability for glue line maintenance. So if the glue line, for example, was to delaminate or the glue to fail before the fire line reached the glue line, then you've got a different scenario there. And we've got that built in. You can see the faster char model built in around the glue line for the first 25 millimeters before it gets insulated and reduces as well. Then following that, you've got your different char rates. So this can be done usually directly from the supply chain. And if the supply chain wanted to, we can hard code it in for the individual suppliers as well. You got the ability for plasterboard protection. So I just added protection in. You can see here the plasterboard adds in, say, for the first, whatever the encapsulation period minutes is. And that's the period where you've got no charring. And then after that, you've got the temperature reaching above 300 degrees here. So there is charring, plasterboard falls off. You've got the faster char rate up to 25 millimeters, and then that's the end of the first lamella. So sort of like, what is the char rate of CLT? You can see right here, there's not one answer. It varies a lot based on basically the building physics or the physics of the fire itself, and it varies upon the input as well of your glue line. So moving through again, if you're not sure what that means, we have the information on the char rates, what it is, and then we've got right here, we've got information from the fire safe use of wood in buildings, was the Global Fire Design Guide, and got some of the data here, which is commonly used in starter charring and failure time. But again, being a performance-based software, which I can talk again a bit about later if we want, that means it's on the engineer to do it. So you can use the data directly from suppliers is most robust, you could say, in that sense. All right, so moving through, it's going to took off encapsulated. We're building out all the analytical methods. So one of the limitations of spreadsheets is you can't really build out robust and quite complex analytical methods. When it comes to span tables, you don't have two span unequal either. So even if we do have, some guides, it's not available for the two span. So moving through there, again, DFMA education. We've got a bit of information on transport limitations here. So helping the education from a DFMA point of view, what's the impact of spans, and then moving through. So you can see here, you got your design where we're failing here. I'll just choose a bigger panel and later we can upgrade that, and it's all dynamic based on what the inputs are as well. All right, so then we've got the design data from A1720. We've recreated the imagery and things like that for the mass timber context as well, so you can educate yourself and have it at the fingertips. So right now you can see there's the NCC, there's a ProHoltz guide, there's Eurocode 5, there's a lot of different guides that engineers would have to download and source, and we're sort of trying to get the education in one place to make things easy. So as a user, you can start going through the computations. So, you might minimize this, minimize the input page and start going through the calcs. It's all dynamic. So right here, we're using an effective stiffness method using the extended gamma method. To solve this, we had to solve 11 by 11 matrices, which again is really hard through an Excel, or can't really be done in Excel like you might want to do it. And through JavaScript, you can solve unique problems that can't be solved otherwise. So that's a complex thing. And we had to do the extended gamma method because, things like the shear analogy method we've got here as an option. It can't be used for non-symmetrical sections as well. So there are times when the extended gamma method is the most powerful. So moving through, we've got the shear force, bending moment diagrams, strength design, not being a black box. We've got all the references for all the sources, as you can see here. And then as a user, you know, at the very end, make sure the design's good, and then you can print. Right now, being early on our journey again, we got the lecture infrastructure being built out. That's not ready yet, but that's again what our intention is to have lectures built in and have a proper timber design and education module that can be leveraged, of course, by universities as well, because I think any student can pick up something as easy as this and actually design confidently in a full project. As I said before, not just mass timber, we are doing light frame and the wider context as well. So design reports, of course, is what's required on every project out there for certification. One of the other problems right now is, like, on that topic of certification, if you do get a mass timber specialist in the mid-rise context, they're using Global RFEM and quite advanced software, not simplified software that's really easy to follow. Sending it to the third-party engineer for certification. They're like, what do I do with this? You know, they haven't used that Global RFEM before, but you know, through this we can actually, it's an easy tool for building certifiers as well. All right, so once we're done there, we can hit save. Moving on to another calculator, I'll use the floor ambient design. Well, before I go there, I'll just show you the project level page. You can see we've got discussion features. You can tag your colleagues if you've been in a meeting and there's a few things to do. You can have a discussion, invite your colleagues as well, so pending invitation, and then assign each of the tasks. So if you've got your senior engineer working on it and you're a grad or something like that, you can divvy up who's responsible for what. So moving through here again, we've got floor ambient design, floor ambient one. You can go from this view as well. You know, later we might combine fire and ambient design in one, but there's a lot going on in each, so we've kept them separate at this stage. But a few users have asked for it to come back into one, because it's one of those things you want to keep it as simple as possible and easy to follow, and it is in its current format. All right, so again, we've got design methods. So let's go, say, XLAM in this case. You've got different design methods, so FP innovations being one. For example, say for vibration, and this is again where we've got the drop down. So there might be some cases where you've got this might make sense. FP innovations is the only vibration method where you can get a benefit for continuous floor spans up to 10 to 20%. So let's say if we were going to do a 2-span equal, then you've got a dynamic. You got the option of the improvement here, as is the case in that method. Or there's the other vibration method. So there's the upcoming Eurocode. It's now 2025 as a different method. This is the only vibration method which lets you specify a floor performance level and a response factor, so which varies based on the building type you've done. So this is the only simplified method that does it. You know, and us being a simplified software solution, there are other software solutions which are more about your FEA modeling and things like that, and hardcore analysis. And you know, Global RFEM, I think that was one of the questions for the what other software. Global RFEM is another one out there which is good in an analysis point of view, but not your simplified method. But anyway, moving through, we've got FE innovations, got your loading data, analytical methods, education on what the methods are. Again, different ones around the world. I like the extended gamma method. Choosing your loading conditions. We're going to constantly be building out this analytical cases and actually do it from scratch. Yeah, and again, moving through, you've got again, you can input all the calculations as we go here, and then use a solver as well. So right now, you could just toggle through the whole supplier panel range, run through it and do it, or we can just hit solve and it'll go through what the most efficient layup is for the supplier based on the vibration method chosen. And then, you know, if you wanted to, you can fix all of these inputs and then change suppliers, and that way you've got a apples with apples comparison, because for the client, it might be best to keep all your options open. If you were to do an overseas supplier, for example, you might change your design methods to Eurocode 5, keep your vibration methods. And as you can see here, it's all dynamic. So Eurocode 5, I'll do that again actually. So you got A1720 design data and A1720 design methods. But if you change it to Eurocode 5 design data updates and Eurocode is actually quite hard to follow, but we've got it in a way that it's a bit easier to follow. So you can easily change your different methods. And in any case, vibration is governing. So it's not going to be the design method in this case. It's going to be your vibration method that governs. So let's go back to that. I think we had a 200 panel working. I think it was well, we're doing a continuous floor span. So I'll go 10% improvement based on the vibration method chosen. We can get a 220 working in that sense. So moving on, usually I just choose one supplier and fix the panel, but because you know, we can't favor any suppliers on a webinar like this, just chose Timberlink and XLamp for two different ones who are all phenomenal. So 1140 now. I'll keep building out just a couple more calculations. So it's got beam design, so GLT beam, and we will. Our intention again is to have LVL in here as well as an option, even though it says it's all about GLT. And this is where you've got the options here. So ash showing sustainable hardwoods are in here. Whenever you've got a supply, you've also got the drop down of the education of the contact who it is. So Nathan Benbow in this case, and it's got a bit of a spiel. I got Daniel Wright's initial spiel, but then change it a little bit for our context. But yeah, Daniel's been awesome to work with as a partner through this. So you got, these are the size of what ash can supply right now. So, you know, you got full confidence of the availability. Also in terms of their grades, if for whatever reason ash needed to make a change, they could just give us a call. We could change it immediately, and then the grades will automatically update in the software as well. So again, moving through, you've got different load combinations. You've got the ability to do manual load combinations with your own K1 inputs for ambient or fire, or you can input forces, and that means you can use microstrand or space gas or a different analysis software and use it and working with it. So moving through, I think we had to say the FRL is 120, char rate. You'd have to speak to the supplier and what the char rate is, but it's 0.7, let's say. I know ash has got better performance in 0.7, but let's just use that for the sake of it. And then a zero strength layer as well. In terms of exposed faces, we've just got the three-sided fire exposure here, deflection, long-term, short-term. Your J2, some suppliers will be less than 2, but two's an input there. And if you're unsure about what any of this is, you know, being a grad, you might be educating yourself. Again, we've got the resources, the references, so someone can really expedite their journey to become a timber specialist. So moving through, again, you got the different cases. So let's say it's a 9 by 6 meter grid. You can hit, we're currently failing for deflection. You can hit solve on D, and all of a sudden we've got a 450 by 920 beam working. Or if you wanted to, for example, you know, fix your floor to floors and solve for your B, for your beam, you can do it that way. We've got a 250 by 1100. So it's a quicker way of doing it, and basically strolling through what the supply chain's got. And then, yeah, moving through, we've got all the design methods here. We are modular, so that means, for example, you might not need vibration for the design of a roof, so you can turn that off and vibration's gone out. For robustness, you might not need vibration or deflection, so you can turn that off as well. So you can just turn whatever off you need. For example, sometimes you might just want your properties and your section modulus and some of these properties to take elsewhere, and that's when you turn everything off as well. So putting everything back on for the sake of it. Got that option there. So what I'm going to do is I'll hit save. See, it's 1144, so I might do a really quick point load calculator after this, and then take it from there. So yeah, you can print all your reports here. So you can scroll, you can toggle the order of everything, do your calculations, get your design report, and these are the things that take a long time to build. So I just did 3 reports. It's 19 pages here. Obviously, when you do a big building, there's a lot more going on here, but it's a way of actually us having a confident way of, you know, a confident solution really to take the industry forward with proven design methods and using that concept of leverage as much as we can. So that's the design report. So moving back, Again, I'll go back to this view here. We've got the point load. This is our most recent calculator. So you got all the different examples I've done there. I'll just do a new office project for one ambient design. And something like a point load, it happens. It's a question I got all the time when I was at XLAM, and the way to solve the problem when I was at XLAM was I'd send ProHoltz would guide to the individual engineers, and they'd have to read it and figure it out and then build spreadsheets to solve the design, which is a big ask. So instead, we've made it. We've solved the point loads once. Something like this is it is quite complex, even though it looks simple. We made it to look simple, but as you move it closer to the edge, the slab edge here, you've got a different BV, your effective width for the shear, for your shear capacity checks and so forth. So we do all those calculations. We have all the different design methods. So again, a section modulus from before, ability to educate the users on it. So as opposed to, again, sending a PDF guide, you actually have the education as if you would have a PDF guide. But not just that, you've actually got it linked into the supply chain as well, and able to use it and just use it straight away, really, and get across your problem. Things like deflected shapes, had to go back to double integration method from uni with the team to solve that one. Action, shear force, and bending moment. And again, education, not being a black box every step of the way. So, yeah, that's where we are now. As I said, we're just starting our journey. Our team's really building up now. We've got the office. We're going to have 15 structural engineers by the end of the year, and looking to partner with the supply chain as much as possible, with a general belief that if we just make things as easy as possible, then we can solve one of these bottlenecks and drive the demand. Because we're not supply constrained, as some might say. We've actually got supply chain ramping up and some capacity in there. So we're demand constrained currently, and there's plenty of room for more timber buildings around Australia and New Zealand. So I appreciate your time, everyone. And Alistair, I think it's 11:47 now, so we can take any questions.
Yes, please, those in the audience, put some questions into the Q&A if you'd like to ask Adam all about. It's an absolutely amazing job you've done, Adam, and I think everyone can appreciate what you said previously, that if you're starting from scratch and you've got to build all this, I mean, I just don't know how you do it for a project. So having a fantastic tool like this is not only going to be a time saver for professionals, but yeah, what you were speaking about before about universities and TAFEs is also going to be critically important. You did make the point that we've tried for many years to get more timber content into engineering, architecture and building courses and at the TAFE sector, but it is a hard struggle, particularly against concrete and steel. So this is really going to be a benefit there. I might come back to that in a sec. I was just going to also ask about carbon. Were you doing sort of something about calculating the amount of carbon that's stored in the timber product?
Yeah, our intention is to definitely do something around there. We're just sort of holding tight. There's a lot of movement in that space, which you're well aware of, Alistair. So it's back to that point of replication. We don't want to reinvent the wheel that someone else is solving other things. But yeah, our best position is the software side. So we'd love to have a software tool for sustainability made by the timber industry that is available for free on a web app, which is what we really want to do. It's like not purely commercial driven thing from us. It would be something that moves the industry forward, because we'd love to get to the point where you can do a system by system comparison. So if you're, I showed you the image before of a structural engineer. Do I do concrete? Do I do timber? There's a I think 70% of structural engineers want to help in terms of sustainability. That was a number by iStructE. If they could go onto a web app and say, this is my PT concrete band beam solution, and you do a mass timber solution, toggle a few assumptions, and then you've got the actual difference in carbon saving, and then to go with that, like translate it. It's always fun to translate it to coffee cups or years lived or things like that, because I think that would help drive change as well. It's just to get that comparison into the hands of engineers. So yeah, 100% on the roadmap. It's just matter of timing.
That's going to be interesting when carbon becomes one of the sort of decision-making sort of requirements that building projects are going to need, and it's definitely heading down that direction. Yeah, how does what you're doing, which is fantastic on its own, but how does it integrate with other software going forward? You know, particularly that sort of 3D side, talking about BIM, all those sort of things, where the market's heading.
Yeah, so a lot of the future is software. It's through APIs. So if that's a new term for people, excuse me, it's called like an application program interface, and that's where software developers allow other software to build on top of each other. And in that ecosystem, there's a lot of startups solving specific problems in that space. So specifically for a structural engineer, a lot of them right now are using automated analysis workflows from something like ETABS or something, or Grasshopper and Rhino, and using these parametric tools that automate a lot of things. And then our intention is to move into that and actually have an API that can work in with structural engineers, workflows like that. And that means we've got a solver, probably like, because what we're going to do best is the best solver, or the best one-stop shop for mass timber design or timber design in mid-rise buildings, and have that connect to the ecosystem. And that's also a conduit for the supply chain to get into those workflows, because you've seen that Grasshopper stuff, Alistair, it's really cool. You got, you know, rather than the current design method where if you got a roof, for example, design and you'd have to go through a variation from the structural engineer in 6 weeks. If you're using something like Grasshopper, it's a bit like an Excel spreadsheet. You just change the roof pitch and everything automates in real time. So yeah, it's an exciting place in software developing, and yeah, we look forward to being part of it.
Mm. And there must be questions from the audience, I'm sure, because I know you all would have found that as intriguing as I did, but there must be some questions. So please put them in the Q&A box if you'd like them answered.
There's a few in chat here, Alistair, as well, I see.
Yeah, I think you answered some of the stuff in the chat. So it was certainly asked about whether the software included result calculations and formulas, which you've shown. I mean, from that point, from a compliance point of view, so how can that be used with getting the projects signed off?
Yes, so compliance is a real hard one, which we're all now aware of. There's like, I think the way I see it, you got some DTS solutions, but they don't solve everything. So there's a lot of individual solutions, and I'll take a step back again. So everyone might have heard in the NCC in 2018, there was this new DTS pathway that was to allow timber into buildings, and it was purely from a fire point of view, where you could have it could be classified a non-combustible material if you've got the plasterboard and all that sort of stuff. But you've also got the other component, which is separate, which is determining the FRL of a building product, which is different, and there are different compliance pathways for that. There are some DTS solutions using fire tests for that, but it isn't all encompassing. That's for fire. When it comes to structural engineering design as well, there's no Australian standard. So mass timber or CLT is not called up in AS 1720, mainly because there's no manufacturing standard, so that's not in there. So from the very outset, you're using a performance-based design from the very start. And there are new reporting procedures around performance-based solutions, and whenever there's that complexity, it just adds to that overall friction there. So we think we're a big step forward, because right now you can, again, solve the problem once, solve what the performance-based design reports are and things like that, and distribute it widely. But we are a performance-based solution. So in the NCC, though, there is a software protocol, and you get to meet the protocol to follow the DTS solution. But because we're not DTS from the very start, the software protocol doesn't directly apply, but we are using the software protocol as inspiration, so to speak. And it's on us to build out the most robust third-party review process. So whilst we're here, Alistair, I might take the screen again. And that means we're going to build out our own sorry, one second. Build out our own third-party review process, because that's absolutely critical in what we're doing. I'm going to log into my back end here. So that's the special way I can do. So you can see we've got alpha calculators and beta. So our internal process is we build a calculator out. That's an alpha. We review it internally ourselves through MathCAD, our own an independent way of checking. Might be a different design guide out there. Then it goes into beta, and then beta is available to users. And then we have a third-party review process from a different engineer to double check it. and then that loses the beta symbol. And again, it's one of those things like some design methods, like in-plane design of CLT, it's really, really hard. It's one of those things I thought I was doing it correctly my whole career, but it turned out I wasn't doing it exactly right. But with this software approach, we can get, say, I won't say who it is, but someone who's got say a PhD in in-plane design on diaphragms to review that and help produce it. Then you've got the best expert, and all those mistakes that would have happened otherwise can be removed. And yeah, so we're doing that the same across fire. Fire, again, it's something that's got that huge subjectivity. We are starting on structural design calculators, but looking to solve fire dynamics calculators as well and have that profession expansion. And again, in that space, say you got the Daniel Brandon method, for example, which is probably a more conservative way, and that's where you use the fuel load of the fire to actually ramp up the char rates on the timber, which means you've got a more dynamic plot. Again, something super complicated to solve once. Solving it once, then implementing it into the structural design calculations before, it's a big problem. And that's where we're trying to solve it once. And through our partnerships with associations like the New Zealand Timber Design Society, New Zealand Timber Design Centre, they're supporting us financially and technically to build out design methods as of the new AS NZ 1720, which again is a big step up in terms of seismic design and difficulty.
There's actually a great question from Stuart here just under the chat that I'll just put to you, Adam. He said, "Hi, Adam, great presentation and excellent software. As this is targeted at engineers, is or will there be something suitable for architects, essentially something much more simple that allows some rules of thumb to work with at the very earliest stages, like the feasibility stage before the full consultation team is appointed?" He says, "As you mentioned, everything currently works to concrete steel structures. To help us move towards timber, we find we have to present something from a very first stage to get real traction."
Yeah, that's an awesome question by Stuart. So yeah, on our roadmap there is actually. So I believe from your perspective, at the start, you just want to know straight away, is it more sustainable? How much does it cost? And how fast can I build it to get those prelims? And what are the savings there? And that's all you probably want to know. And then to get that decision brought up early and really quick. The current way that's done, unfortunately, is if you got that question, you need to find a fire engineer who's done it before. You need to find a structural engineer who's done it before, quantity surveyor who's done it before, get it done properly in terms of sustainability consultant. All of that's done through a long process of meeting after meeting. And if you don't have the A graders in the room, like I mentioned before, it's going to be hard to get it across the line straight away. So yeah, part of our intention is to help with that specific process. I probably don't want to, we can chat offline, Stuart, but we do have something. It's probably like 6 to 9 months away at least, I'd say. But it is the idea in terms of bottlenecks. Have all that information very upfront, and you can take that through your detailed design to help you make decisions.
Fantastic, Adam. We're just getting near the end of time now, but I'm sure people are wondering if they're keen to sort of see the software and play with it a little bit more or speak to you about it. What do they do?
Yeah, great idea, Al. So I seem to always be an engineer and not a salesperson. I seem to forget the most important things sometimes. But yeah, so right now it will be publicly available later in the year, around about October, November. But we do right now have beta users on the software, and it's a big discount because you're basically getting the unfinished version of the software. I mean, I'd say it's much better than spreadsheets and stuff like that right now already, what the alternative is. So if you want to get early access, I recommend going to the website, clttoolbox.com.au, and then, thanks so much, Tom. That means a lot. And then, send us an email through there. Or my email is I'm going to put it in the chat now, adam.jones@clttoolbox.com.au. And yeah, keen as to hear from you, get users on as early as possible. I'm getting married in August, so I'll be offline a little bit. So we're trying to get the public release where there's going to be spot 5 bit after that.
Fantastic. Thanks, Adam. It is really amazing bit of work that you've done, and it's just going to really propel things forward. As you mentioned, there's a bit of a bottleneck at the moment, even though after 5 or 6 years, with the good work you did under the Midrise team, we've got a lot more building professionals far more attuned and understanding of mid-rise timber, particularly engineers who are one of our biggest bottlenecks originally, so that they feel confident in design. But we definitely want more sort of architects, building designers, building surveyors, all of those people quite sort of happy with mid-rise construction. So thanks for a fantastic presentation today. Just a reminder to everyone that the webinars are recorded. So if you want to go back and have a relook at this or let your colleagues know, just go to the WoodSolutions website and under that webinar tab. We've got a couple of webinars coming up I just want to let you know about. We've got a special one actually next week on the 12th of July on the benefits of timber framing. Let's build a better world in conjunction with the Timber Frame Collective and with MyTech. So I'd encourage you to tune into that one. I think you'll find that one of interest. And then in our regular monthly WoodSolutions webinar in August will be from Alf Morocco from Belvedere, talking about the key lessons on timber installation. So that'd be actually really interesting to hear from that sort of practical installation point of view. So hopefully you can join us for that. We thank you once again for joining us today, and we hope you have a great day and a great week.